So we're going to give you an equation. We're going to practice balancing it in acid. So here's the equation real quick. Permanganate and sulfur dioxide makes manganese with a +2 and sulfate ion. Okay, first thing you're going to have to do is assign oxidation numbers. All right, you've noticed that I added the oxidation numbers. The manganese starts out at a +7 right here, goes to a +2 over here. That means it gained 5 electrons. To go from a +7 to a +2 is to gain 5 electrons. The sulfur, on the other hand, went from a +4 to a +6. That means it lost 2 electrons. So those are the ones that were oxidized and reduced. The oxygens didn't change, so we're not worrying about them gaining or losing electrons. So let me write 2 half reactions. Let me split this in half. All right, you can see that I've added in the half reaction. Manganese goes from a +7 to a +2. So to check it for charge, we've got 2 permanganates. That's each has a -1 charge. 2 times the -1 is -2. The water is neutral. The sulfur dioxide is neutral. So we have a total charge on the left-hand side of -2. On the right-hand side, 2 manganese with a +2 charge is a total of +4. 5 sulfate groups is a total charge of -10. So a +4 and a -10 is a total of -6. And then we have 4 H pluses. So we had a -6 and a +4 makes it a total charge of -2. -2 on the left, -2 on the right. This equation's done. It's balanced both for elements and also for charge. Permanganate and oxalate makes manganese dioxide and carbonate. You assign the oxidation numbers real quick. All right, so the only oxidation numbers that change are manganese going from a +7 to a +4, and carbon going from a +3 on oxalate over to a +4 in carbonate. You do the same thing. You split it into 2 half reactions. Let's see what those look like. All right, there are your 2 half reactions. Manganese gaining 3 electrons, oxalate losing 2 electrons to become carbonate. Forgot my -2. All right, so your next step is to take each half reaction and you want to balance it for oxygens using hydroxides and water, and you want to do the same thing with the oxalate one. So take a stab at that. You want to balance the O's with OHs and balance the H's with water. Go back to your steps and see how that's done. Let's see what the answer looks like. All right, so if you look, I balanced it with hydroxides. I added twice as many as I needed to the right-hand side. That's what the rule says. Then you balance the hydrogens with water, which you notice I've done. I'll do the same thing to the oxalate. All right, I did the same thing to the left-hand side. To the bottom equation, sorry. I had 6 oxygens on my right. I needed 2 more, so I doubled that. That's where I got 4 hydroxides from. Then I have 4 H's. I had 2 waters to balance that out. The next step is to make electrons lost equal to electrons gained. So what number do 3 and 2 have in common? I'll have to multiply this top equation by 2, the bottom equation by 3. And when we do that, we ought to be able to put them together. So you guys multiply those equations through, add them together, see what you get. All right, notice the black line up here, right there. That's what I combined from the left-hand side of the equation. The red down here is what I did on the right-hand side of the equation. Now, find the things that are the same left and right and cancel out. Find the water and hydroxides and cancel out. All right, you can notice I canceled out the waters, and here come the hydroxides. All right, now, if you look at the carbons, they're balanced. The manganese is balanced. The oxygens are balanced. You need to check it for... So now all we have to do is balance for charge. So we've got 2 negative signs. That's -2. 3 times -2 is another -6. So that's a total of -8. 4 more is a total of -12. So over here we're talking about -12. On the right-hand side, on the red side, that's no charge. We've got 6 things with a -2 charge. 6 times a -2 is -12. So -12 on the left, -12 on the right. The charges balance out. This equation is balanced, both for elements and for charge. So we're done. Hi, welcome to podcast 4.4. This podcast was actually made by Michael Burleson, a student of mine in 2014. He's just going to work an acid redox example. I just assigned this in case you wanted to see one more example worked, one more thing of practice. So enjoy.
Hi everyone, and welcome to this podcast on balancing acid redox reactions. Pause and try to assign the oxidation state of this reaction. Go ahead and do it. I said pause. Have you not paused yet? Pause. Alright, well let's see. These are the oxidation states. If you did not get this, that's okay. I'm going to explain how to do it. First, look at Mn. It has a charge of +2, and since the oxidation state of a monatomic ion is equal to its charge, the oxidation state of this ion is going to be +2. Next, we have BiO3. First, we need to look at the oxygen's oxidation state to figure out Bi's. Since we have 3 O's, we need to multiply 3 by -2 to get the oxidation state of all the oxygens, which is going to be equal to -6. Now, since the charge of the ion is -1, and the sum of the oxidation states is equal to the charge of the ion, we're able to deduce that Bi's oxidation state is going to be equal to +5. You can use the same technique for finding Bi's oxidation state as well as Mn's. And you can also use the same technique for finding MnO4s as you did with BiO3. So now that we have all the oxidation states worked out, we can balance the reaction. So now what we're going to do is we're going to go through the steps to solve this problem. So we have step 1, splitting the reaction into 2 half reactions. So let's see here. We have this right here. Now you're probably wondering where I got the -5e from. Well, that's just the amount of electrons that were transferred from the manganese to the manganate, because things don't just magically happen like that. Something has to go. And we do the exact same thing with BiO3 right there. Steps 2, 3, and 4. I combine these steps because they're all, it all kind of happens at once, and it's, yeah. So, let's look. We need to balance the H and the O's. So let's look at the first half reaction. Since manganate has 4 oxygens, we need to balance the other side with 4 waters to give it the same amount of O's. And now since we have 8 H's on the left side, we need to balance the other side with the same amount of H's. Then we can do the same thing with the other half reaction that I did right there for you guys. Alright, steps 5 and 6. I also combine these because it's kind of, they kind of go together. So, now that we have balanced the oxygens and the waters, we have to balance for electrons. So to do that, we need to find the least common multiple of 5 and 2. Right there and there, which is going to be 10. So you have to multiply each reaction by a number that would get you 10. So here's it continued, and these are what the reactions look like after they've been multiplied out. Alright, might want to get those down too. So, step 7. Now all we have to do is add them together, and cancel everything out. So, here is that reaction. As you can see, I've already done that. So all you need to do now is check to see if the charges are balanced. So you do basically find the new oxidation states. You have 2 and plus 2, which equals 4, 14, -5, because there are 5 there, -2, 15, and 0. And guess what? They equal each other! Woo! Yay, cheering. Alright. So, now, that's really all I have to do for assigning acid oxidations. Not assigning acid oxidation states, doing acid redox. So now I'm going to be a jerk, and I'm going to give you a problem to try, because I feel as though practice makes perfect. And you might want to look at a little bit, because you've got a 2 right there, and you've got only 1 chromium right there, so that might come into play a little bit later on what you might have to do. So that's it for this podcast.